Hello, boys and girls. Today's lesson, or this week's lesson, is on stem and leaf plots. Um, the next lesson will also be on histograms, but today we're going to be going over stem and leaf plot. Stem and leaf plot is a data display that shows groups of data arranged by place value. So here you would see an example of a stem and leaf plot. It says to make a stem and leaf plot, the data set is sorted in ascending order, meaning it goes in from least to greatest. So this is actually the stem and leaf plot, and it goes in order from least to greatest. See how it goes in order from least to greatest, and least to greatest, least to greatest, least to greatest, so on and so forth. Okay? So basically, this stem and leaf plot is for this data that's right here. Luckily for you, they also put the numbers in order from least to greatest. And if you notice, they're using the stem as the tens place and the leaves as the ones place. It says multiply the stems by 10, multiply the leaves by 1, or you can combine them. Sometimes there'll be a key and they'll say this and then the slash and then this means 16. So that way you know what each one represents. And I'll show you in the examples what I mean. But see how here we have 3, 7, 16, 24. So because there is no tens place here, you would write 3 as a 0, 3. This right here, see 0, 3, so that's 3, 7. Then you have 16, 24, 25, 29. You have 31, 34, and then you have 40, 42, 42, and 49. Okay, so that's how we do the stem and leaf plot. If you ever want to know how many are total in the plot, you just count the leaves. So when there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 numbers. And if you notice, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up here also. You do not count the stems. You count the leaves to find the total. Okay? All right. So let's go ahead and get started with our examples. So it says, example number 1, it says, a local car dealer recorded the average miles per gallon of gasoline for each of the new cars on his lot. He used the stem and leaf plot shown below to represent the data. So it says mileage per gallon of gasoline. So basically they're saying this car had 19 miles per gallon. This car had 19. This one had 23, 24, 24, 27. And if you want to, you don't have to just look at the stem and leaf plot. If you want, you can put your numbers on the side. Like, for example, we know this is 19, 19, 23, 24, 24. There's 3 27s. There's 2 28s. There's 31. See that? 31, 32. 34. I don't have space, but I'm going to put 35, 40, and 41. So just like that. Or you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 16 total leaves. Okay. It's just basically up to you. I would probably just keep the stem and leaf plot the way it is, but it's entirely up to you how you want to do your data. So it says, how many new cars got better than 30 miles per gallon of gasoline? So you look at this stem and leaf plot. So better than 30 miles means more than 30 miles. So basically you want to know or look and say, okay, well, 31 is greater than 30 and everything above. So I know there's 1, 2, 3, 4, 5, 6. 6 numbers better than 30 miles. Or you can look at this numbers. That's more than 31. So is this one. So is this one. So is this one. So is this one. And so is this one. So there's still 6. So it doesn't matter which one you want to use. Still gets the same answer. Okay. What is the difference between the car with the best miles? So difference between the car. So they want to know the range between the best miles per gallon and the worst miles per gallon. So the best miles per gallon would be 41. So 41 minus the least square would be 19. So obviously we borrow. 11 minus 9 is 2, and 3 minus 1 is 2. So the difference is 22 miles per gallon between the car with the best mileage and worst mileage. And finally, what is the most common? They're basically asking you for the mode. The most common number of miles per gallon on new cars on the lot. So which one is the number that appears the most? Now you can look at these or you can look at these. If you look at the stem and leaf plot, it's very obvious. This 7s appear a lot more, and these have only 2. But if you look at the 7s, they go with the 2. So 27. 27 is the mode. Or you can look at these numbers and you can see that 27 appears the most. Okay? That's how you do example number 1. Example number 2. Ben's Donuts recorded the number of dozens of donuts they sold each day for 20 days. So 20 days. So that means there's 20 leaves. And if you look at it, that's 12, 13, 14, 15, 17, 18, 19, 20. There's 20 total. Okay? Sometimes they give you the total, sometimes they don't. You have to count the leaves yourself. But they're saying basically this day they sold 12 dozen. This day they sold 15, 18. And I know that because the key tells me that this is a 12 dozen. So that's 10s and 1s. So again, you can put the numbers all on the side or you can just use the stem and leaf plot. I'm going to go ahead and just use the stem and leaf plot to get practice. How many days did they sell more than 20 dozen donuts? So that's 12, 15, 18. Those are not more than 20. This is 20. This is 20. Well, it's equal to, not more than. So this is 25. Okay, so everything from here all the way over here, all of that is more than 20. So I count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 days they sold more than 20 donuts. What was the largest amount of dozens they sold? Remember that stem and leaf plots go in order from least to greatest. So greatest would be 41. 41 donuts. 41 donuts is the most dozens that they sold. And what amount of donuts sold was the most common? Again, they want to know the mode. So you can look at the leaves. Which is the leaf that appears the most? Ooh, these right here. And they go with the 2. So that would be 25. That is the number of the most common amount of donuts sold. 25. And that is how we work it out. So you have 4 questions on your independent practice. I would like to do I would like to do 2 examples with you. Okay, I would like to do number 1 and number 2 with you. So basically I'm going to do 2 problems with you. So all you're responsible for now would be the 2 last problems and to submit your assignment. Okay, so the stem and leaf plot shown below was created to represent the set of data collected about number of books read in a 2-month period by a group of students. So here's the number of books read. Okay. Now it doesn't tell you how many total students there were, but if you count the stems, 13, 14, 15, 16, 17, 18, 19, 21, there's 25 students. So the total is 25 students. So basically this kid read 1 book, 2 books, 5 books, 6 books, all the way down to 31. Whoa. But it says, which is the data that's not true? We want to know who is false. So it says the 7 students read less than 10 books, less than 10. So we know that if this is 10 right here, all of these are less than 10. So 1, 2, 3, 4, 5, 6, 7. Is it true that 7 students read less than 5 books? I'm sorry, less than 10 books? True. The most number of books read by any student was 31. The most number of books read by any student was 31. This is the largest, 31, so that would be true. Now we go into percents, and we all know that for percents we use part to total percent out of 100. So let's do C here. Part to total percent out of 100. I know that there's a total of 25 students. 100 always goes here. I'm looking for X. And exactly 10 books. So exactly 10, we have 1, 2, 3. So 3 students. So let's go see if we get 12%. So it says, so we're going to work it out algebraically. So 3 times 100 and 25x, that would give us 300. We divide by 25, and what you do to one side, you do to the other. That becomes a 1, and 300 divided by 25. 25 does not go into 3, but it goes into 30 one time. And 25 goes into 52 times, so that would be 12%. Ooh, that matches, so that's true. So by process of elimination, we know that our answer is letter D. But we always want to double check, so we're going to go ahead and double check over here. So 75% of the students read more than 10 books. More than 10 books. So you want more than 10 books. This is 10, so everything over here is more than 10 books. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 out of 25 and X out of 100. So we're going to go ahead and work it out algebraically, or if you remember, I told you guys that sometimes we could have shortcuts. So you can work it out algebraically if you want to make more sense of it, but I also see that 25 times 4 is 100. So 15 times 4 would be 60. That is not 60%. False. And it works with this one too. Look, 25 times 4 is 100. 3 times 4 is 12, and that's what we got. Now remember, this trick doesn't always work. This always works. But because 25 goes evenly into 100, I was able to use this shortcut. Okay? So our answer would be letter D. Number 2. It says the number of cars in a parking lot at noon each day for 2 weeks is shown on the stem-leaf plot. So cars in a parking lot. 0, 5 means 5 cars. So that means these are 10s and these are 1s. Which statement is true based on the data in the stem and leaf plot? At noon, on exactly one day, there were 15 cars in the parking lot. 15. That would be false. Because there's 10, there's 14, there's an 18, but there's no 15 anywhere to be found, so those are lies. G. The parking lot has less than 10 cars at noon on 3 days. Less than 10 cars. So if this is 10, then 5 and 7 are less than 10. That's false. There's only 2 days where the cars are less than 10. False. Only 2. H. The most number of cars in the parking lot at noon was 39. The largest number is 39. True. 1/2 of the days during the 2 weeks, there were less than 26 cars at noon. 1/2. So if we count these, that's 4, 8, 9, 10, 11, 12, 13, 14. If it was a total of 14, then half is 7. Now, were there 7 cars that were less than 26? Less than 26, that's 26. So that means that these are all less than 26. That's 1, 2, 3, 4, 5, 6, 7, 8. That's a lie. There's 8 that are less than 26, not 7. So H is my answer. Okay, so you guys go ahead and work out 3 and 4 on your own, and then you can submit your work. You guys have a great day. Miss you.